Welcome. Today we're talking about how to find the area of regular polygons, but when you have to use Pythagorean theorem. First, let's review what we did in the last video. We found out that you can find the area of any regular polygon when given a side length and the apothem length by using this formula. So n is the number of sides, s is the side length, a is the apothem. But what if you're given the radius instead? So here we have a pentagon. We've got our 7 as our side length and a radius of 6. We can use our isosceles triangle skills. Since the radius is 6 out to that bottom right corner, it would also be 6 out to the bottom left corner, which means we have blocked off an isosceles triangle here at the bottom. Now, let's just focus on that isosceles triangle for a minute. If we draw an altitude from the vertex, so all the way down, straight down the middle, that altitude is the height of the triangle, but it's also the apothem of the pentagon. So that's kind of nice. Remember, what we look at here, though, is that instead of considering the entire base of 7, we just want to look at half of it on each side. So with the 3.5 for the right triangle on the left, and the 3.5 for the right triangle on the right. If you saw our isosceles triangle video, this should not be a new process to you. If you haven't seen the isosceles triangle video yet, there's a link up at the top. But we can use Pythagorean theorem now since our isosceles triangle got split into two right triangles. So the 3.5 at the bottom, the 6 that was originally a leg of the isosceles triangle is now the hypotenuse of the right triangle that we're doing. So it ends up being the C in our Pythagorean theorem. Now we'll just calculate this out. So a squared plus 12.25, which is the 3.5 squared, and 6 squared is 36. We'll subtract the 12.25 from both sides, and we get a squared equals 23.75. But we don't want a squared, we want the actual a. So we'll just take the square root of both sides. And a ends up equaling 4.873. This is all going to come back into our pentagon. So we'll bring this triangle back. Now the height that we found using our isosceles triangle skills, that is our apothem. So we know the a for our new formula is 4.873. So let's fill in what we know. We're looking for a, we're going to leave that as a. But we know this overall shape had 5 sides, so that's our n. S was our side length. We were given that earlier. That was 7. And A, we just found 4.873. As we work through this, I find it easiest to go ahead and multiply out that 1/2 first. So 5 times 1/2 is 2.5, and then we still have our 7 and our 4.873. Multiply all 3 of those together, we get 85.2775. Once we're ready, then we will round to the nearest tenth, and we have 85.3 square units. Let's do another example. Let's find the area of the heptagon below with radius 7 and apothem length 6.3. Again, we're still going to use our area of the triangles idea, but we don't have the base anymore. We don't have the side length of the actual pentagon. So we need to find this. If we focus on that right triangle that gets made using the apothem and the radius, then we again can use Pythagorean theorem to find that third side, which will be the base of that triangle, which will be half of the side of the heptagon. So we have a squared plus 6.3 squared equaling 7 squared. We'll go ahead and square those out. A squared plus 39.69 equals 49. Subtract the 39.69, we get a squared equaling 9.31. And again, we don't want a squared, we want just a. So we'll square root both sides. And we get a equals 3.0512. This a, we used a because Pythagorean theorem traditionally uses a squared plus b squared equals c squared. But that just represents the third side of our triangle. So this actually pops up there at the bottom. The 3.05 is the third side of the triangle. Let's see this go back into our heptagon. 3.05, you can see now, is just half of that side length. So together we have 6.1 as the overall side of the heptagon. So let's go ahead and plug this into our fancy area of a regular polygon formula. We know there are 7 sides in this heptagon. If you know what the word heptagon means, you know it's a 7-sided shape, or you can just look at the picture and count that there are 7 sides. Then S, we just found S is 6.1. A, we were given originally is 6.3. So again, I like to multiply out the 1/2 first, so that gives us our 3.5. Then when you multiply all 3 of those numbers together, we get 134.505. Then we will round to the nearest tenth for our final answer and throw our units on there. Since this was area, it's square units, and there we go, 134.5 square units. So just to summarize, remember that as long as you're given 2 measurements in the polygon, you can still find its area. You just might have to use Pythagorean theorem first. So thank you for joining me, and I'll see you next time.